All right, guys, so let me just try to share my screen, then we are going to proceed for the day. Today, we are going to be introducing smart contracts in Cairo, how to write smart contracts. Yeah, so like I said in the last class, Cairo is the language for writing smart contracts in Cairo and also for building programs. So what we are going to be looking at today is Cairo, but the smart contract part, not writing normal programs, which is not that hard or not so difficult. And then we'll try to look at some tools that we can use to build in Cairo, then or in StarkNet. Try to build a very simple smart contract and hopefully deploy it if time permits us. So with that, it's going to be the end of the class. So for now, let me just share my screen and then we get started. So can everyone see my screen? All right, cool. All right, so for those of you that have checked out the Cairo documentation, this is a Cairo book. I'm sure I shared it in the last class. And then prior to this class, there are a few things you are supposed to learn before you go into writing smart contracts directly on Cairo. You all will agree with me that this is a new programming language we are learning. So as it is a new programming language, we need to learn some basics about it before we can be able to write smart contracts or build stocks with it. All right. So remember, for the sake of the time for this boot camp, we are jumping straight into the smart contract. So along the line, we'll try to figure out and learn a little bit of the basics while writing the smart contract itself. But on a norm, if you are working with Cairo, you can start from this documentation. You can start from the intro, getting started, to writing your first Hello World program. It looks something like this. Something as simple as this, which is what we do for every programming language, right? HTML, we try to write Hello World. JavaScript, we try to write Hello World too. So if you want to start completely from scratch, you can start from here and then move to understanding variables, data types, blah, 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 understanding complex data types and other concepts about Cairo. But directly, we are just going to try to build or write smart contracts with Cairo today. So we're already in that module, which is about, what chapter is this? About chapter 15. That's where we jumped and where we are starting from now. All right. So another perfect location to start to learn about Cairo in a gamified way is to learn from the StarkNet challenge. So I'm going to be sharing you guys a link now and give you a little bit of what it looks like. So I'll just mention the StarkNet app. So in this app, you can just connect with your GitHub and then you are good to go. Start trying out little things about Cairo. So what happens here is they give you short exercises or simple puzzles or codes that have a little bit of bugs, and then you try to solve it yourself. As you can see, I've completed the challenge. So if you head over to this link, let me send it in the chat. You can be able to connect your GitHub and then start from the introduction. So they will explain how everything works for you from the first exercise until when you try to complete this. So as soon as you complete the StarkNet app, just know that you're already a Cairo ninja. And in the process of building with the StarkNet app, you are going to be learning from scratch, like from the hello world that we skipped. So how this works is the best way to learn Cairo and the most introductory part that everyone uses is using this StarkNet app together with the Cairo book. So you will read the Cairo book, then whatsoever you learn from the Cairo book, you come and put it into practice here. You can also check out StarkNet by example, or Cairo by example. Obakar is still enjoying Salah. But regardless, even within the Salah, he's still joining class. So that makes sense. All right, so enough of that. So you together with the Cairo book, as you can see, if I switch back here to the Cairo book and I go back to the introduction for getting started, try to read this, understand all these stuff, how the architecture works, try to do the installation down to the hello world. If you do all these stuffs, you see it's completely related to this book. So first and foremost, after the intro, the first thing is from variables. So if you go here and you start reading from variables, anything you read from this chapter, if you read like the whole of variables, that's chapter 2.1. So if you put whatever you learned there into this variables challenge within the StarkNet app, you try to solve the problem, then you know that, okay, I've understood this and I'm good to go. So this is just the best way to learn Cairo, in my own opinion. And it's the best way that virtually everyone that I know that has been writing Cairo for long also passed through this process. So I will advise you also do the same as a complete beginner. So enough of the StarkNet app. We're not going to be looking at this, but within your own time, your own free time, just try as much as possible to visit this. Trust me, it's a fun and interesting way of learning. All right, so back to the book. So let me just try to introduce like a few stuff before we go further, like some variables in Cairo, and let's understand how they work. So just like Solidity, Cairo and Solidity have like similar language, what's it called? Similar data types. Talk about unsigned integers, they still exist here. but this time around with a different name. Integers also exist here, booleans exist here. But then there's one particular data type, which is FEL 252. So FEL 252 is like the default data type in Cairo, as you can see it here, FEL 252. So these are just the primitive data types I'm talking about. That is data types that contain just or can store just one variable. I'm not talking about compound data types now. So it has the same integer types, mostly regarded as from this. This is for unsigned integers, regarded with U8, U16 as the bit might be, or as the size might be, down to U256. So you can also see U size. U size is the same thing as U32. So as you can see, the length is the same thing as 32 bits here. And then the Boolean type, either true or false. Then we also have strings here, but they are not used like the normal strings that you don't use them like normal strings. Because JavaScript devs, if you try to use a string maybe with a single quote in Cairo, it is being regarded as FEL 252. It is not regarded as a string. So there's nothing like, let's say, strings in JavaScript, like strings directly. So strings are hiding behind some data types that you can use as string. Like take, for example, FEL 252. So if you want to store like a string-like value that is the length of about 31 characters, you can store it as FEL 252. But if you also want to store a string-like value that's longer than 31 characters, you are going to be saving it as a byte array. So that's also another data type that we are going to be looking at. So this is it, byte array strings. So byte arrays are mostly mostly denoted with double strings. So anything you see with double quotes is a byte array. So this is an example in Cairo. So we are trying to instantiate a value here, a variable, and then we say let long string. So this is long because it's longer than 31 characters. So that's why we're making it a byte array. So if you try to make it a FEL 252 and it's longer than 31 characters, you are going to be getting an error. Yeah, so enough of the byte array and this for now. Then we'll make a stop at compound data types. Let's not look at that for now. Let's go back to variables. So variables in Cairo are mutable by default. So Cairo uses an immutable memory model. So that means any single variable you initialize in Cairo is immutable, meaning it cannot be changed. But then there's a workaround. By using the mute keyword, you can choose to make that particular variable mutable. And that doesn't mean that for using the mute keyword, you can still change the value. So by default, it is immutable. But this time around, what is happening is, if you use the mutable keyword, it is going to like allocate a new location to the variable. And then that new location is going to be where it's going to be pointing at wherever you are looking for that variable. So variable are mutable by default, immutable, sorry, by default, but you can choose to make them mutable with the mute keyword. So this is an example. We have inside of this main function, this variable x being initialized as 5. So if we try to console.log it here or print it, we are going to get this x. But if we change x to 6 and try to get this, we are going to get an error here which says cannot assign to an immutable variable. So for us to make this possible, to change this value to 6, all we just have to do is we add the mute keyword in front of x. So with that, we can be able to change this and everything is going to work just fine when we try to run the program. All right. So we also have constant data types. oh, sorry, constant variables, not data type, sorry. That is, variables are constant, and then bunch of other stuffs. So these are just the few we need to know for now. Okay. So the next thing we are going to be looking at is tools to build in Cairo. So to build like your normal Cairo programs, if you start from the hello world, it's going to advise you to do from the installation. There are certain things you need to get installed to get started. So let's just have a look at some of them. So you need stuff like Scarb. Scarb is the same. Scarb. Sorry, guys, a call interrupted. Guy, all right, so these are some of the stuffs you need to install. So Scarb. So let's look at this. Uh, so Scarb is the same as is the package manager. Scarb is the Cairo package manager. You can use this to get all your dependencies and then run all the necessary stuff you need. Scarb is just the same as npm to Node.js and Cargo to Rust. So these are one of the things you need to install to get started. And then I think you need stuffs like the StarkNet CLI, StarkLi, and etc. But that's if you want to build like normal programs also. But as a builder in the StarkNet ecosystem, for a very long time, I've been working with, ever since I started writing smart contracts with Cairo, I have been working with StarkNet Foundry, which is what we are going to be working with today for the course of this class. So if you are from the Ethereum ecosystem, StarkNet Foundry should not be, sorry, Foundry in itself should not be anything new to you because you must have used it to build like with Solidity, right? So it's still the same concept here in Cairo with StarkNet Foundry. But this time around, it's just the StarkNet implementation of Foundry. So let's have a look. So with StarkNet Foundry, what's StarkNet Foundry? So StarkNet Foundry is a tool chain for developing StarkNet smart contracts. So this is the #1 tool that we are going to be working with. And then I advise everyone to install this tool to get started. So it helps with writing, deploying, and testing your smart contract. And it is inspired by Foundry. So like I said, if you have been working with Foundry before, this should not be anything new at all to you. The only thing new is just going to be the Cairo that you are writing. So let's start from the installation process. So StarkNet Foundry is easy to install on Linux, Mac OS, and Windows. In this session, we'll walk through the process of installing StarkNet Foundry. So you can look this. To install StarkNet Foundry, first and foremost, you need Scarb installed. And your Scarb version has to be version greater than or equals to 2.85. So make sure you have Scarb installed before you can be able to install StarkNet Foundry. So you can also go through the installation process to make this work out. So you can install it also using, so this is the process of installing Scarb, in case you want to follow it. So you can follow the StarkNet Foundry. First and foremost, you can install ASDF. So with ASDF is like NVM. You know how NVM is to NPM and Node.js. So with NVM, you can easily switch packages, right? Sorry, you can easily switch your node version. And then any version of project that is being shared with you to work with it, you can use NVM to switch. Maybe let's say you are using version 20 before, and then the new project someone sent for you to work on is version 21 of Node.js. So instead of you going to uninstall your version 20 and then installing version 21 again, all you can do is with NVM, you can easily switch your version. So from 20, you can switch to 21, and then you work with it to be compatible with the version that you have. So that's the same thing with ASDF. So with ASDF, you can easily switch versions of Scarb and the rest of them. So you can follow all this process to go through the installations. So if all the installations went fine, so you can see the method to install it. If all the installation went fine, you just check with SMForge version and the SMCast to verify that everything is. If you see the versions, it means the installation went on successful. So that's just it for the installation. So that's just it for the installation of StarkNet Foundry. So let me also share this link to you guys on getting started. So mostly the Windows method is being done with WSL. And then for the current stage that you are now as a dev, I wouldn't advise you still working with Windows. I must have said that like times without number. And then the next thing is for you to install like the Universal Sierra compiler. So this one is needed to compile your Cairo code down into Sierra. And then with this, we are good to go. So we can next now we check our first steps with working with StarkNet Foundry. So there's basic commands you need to know when working with StarkNet Foundry, and then that's what we are going to work in these simple steps. So for now, you don't need to know like the whole bunch of stuff. All you just need to know is the simple commands for now. That is, first and foremost, the command to spin up a repository for you, or a repo for you to work on. Just like how you spin a React project with Create React app, you can use SMForge to spin it up. And then with SMForge new, is going to create a new project. Just like how in Hard you can just do Hard init or Hard install before you do the initialization of the project. Or also with Foundry, how you can just do, with Foundry, how does that work? It's belong I wrote Solidity and Foundry stuff. Yeah, but then there's the way of doing that. But with StarkNet Foundry, if you install StarkNet Foundry, first and foremost, it gives you access to two things. The first thing is SMForge, which is this one. So with SMForge, we can use to run our tests, we can use to spin up a new project and then work on it. Then with SMCast, as soon as we have, the second thing is give you access to is SMCast. So with SMCast, we can be able to make interactions with our smart contracts, interactions with states, and a lot of other stuff. So the first thing we are going to work with, this is the first command we need to know, the command to initialize a new project. So to start a new project with StarkNet Foundry, you run SN forge new, then you write the project name you want to work with. So in this case, we said SN forge new, then we said hello StarkNet. So by default, SN forge new creates a project with a simple hello StarkNet contract. So by default, this is what it creates. But then you can use the template flag to determine what you want to get created for you. But as well, we can just use this command, then we clear whatsoever is there and then get started. So the next command is the SN forge test, which is the command you can run when you want to test your smart contract functions, when you have written a test and then you want to test them out. All you just have to do is run SN forge test, and then all the test analytics is going to be, all the tests are going to be run, and then you see the results out. All right. So while working with SN forge, you also be working with Scarb along hand. So this is a short explanation. Scarb is the package manager and build toolchain for the StarkNet ecosystem. Those coming from Rust will find Scarb similar to Cairo, just like what I said before. So it is meant to manage dependencies and also build contracts. So with Scarb, if you have written your contract, if you want to build it to use Scarb, we just the command Scarb build, and then it's going to try to build it, tell you errors if there are any. If there are no errors, everything is going to get finished, and then you are sure everything is working fine and it's ready to be deployed. Yeah, so let's not talk too much about this. And then this might be confusing, so let's not look too much into the project configuration. Let's just try to build a simple project and then see how everything goes. All right, so these are some of the SN forge commands. First and foremost, let's start from the test and see what it does. So with SN forge test, it runs tests for a project in the current directly. This is what this command does. And then these are other sub things you can add to it to determine what it's going to do for you. Like if you want to see the trace, transactions, etc. So next is the init command. So the SN forge init creates a new directory with a SN forge project. So this is how this one works. With this init, it's just like new. It can initialize a new project for you. So the init command is deprecated. Please use the new command instead. So for now, init doesn't work, as you can see from the warning. So the advisory will work with new. But init and new are doing the same thing. So SN forge new creates a new StarkNet project at the provided path that should either be empty or does not exist. So the path is like what we add extra after here, or if it's going to be a project that does the path with the path that does not even exist, we can just call the StarkNet SN forge new, and then it gives us the next step to spin it up. So the next one is to clean. So it removes files generated by SN forge. That's what SN forge does. SN forge clean does for us. And then next, clean cache. So these other ones, I haven't tried them out, so I don't think I am in a better position to explain this. But you can as well check it out and go extra miles to see how they work. So these are for the SNForge commands. So now let's try to use this and then get to go. So let's start with SNForge new and then create a project. So let me just go to my, and then I create. So I'm going to be spinning up a project from my terminal. So can you all see my screen? Yeah, Toby, you have a question?
What OS are you using?
Mark,
What OS are you using?
Mark OS.
Okay.
Yeah. All right, so let me just try to spin this up and we are good to go. So the command to get started is SNForge new. All right, sorry for that short. I had to tell someone bye. Okay, so what do we type in here? Let me clear this so that it goes back up. So the command is SNForge, and then I'm going to use a new command, then type in the path. That is the project I want to work on. So in this case, I'm going to call this what now? Let's call this FiTech contracts. Let's call it FiTech StarkNet contracts. So why is the new one recognized? But init is working. Init, like I said, is deprecated. Because I know I've been using this init. So let's try to code it. So let's open it. So this is the file. And then let's see what it gives us and look at the anatomy of an SNForge project. So this is one. This is what it looks like. So first and foremost, we have the source folder. So this source folder is where like most of our code is being written. As you can see, this is the hello StarkNet contracts that they say they had. So all our contracts, our components, everything we need to write are going to be written in the source. And then next we have the test folder. So this is where all our tests are going to be written. Next we have, everyone knows the git ignore, right? Scarb.log, let me not talk about this. But let's jump to like the most important file we have here, which is scarb.toml. So in this file is where all configurations are being done for the project. In this file, this is where all importations have been done. All dependencies are being managed. Like take, for example, you look at this file like your package.json file as a JavaScript developer. Are we clear? If you're a ROS developer, you look at this as your cargo.toml, which is the same thing as scarb.toml, right? So toml is I think it's a markdown language. I've forgotten the full meaning, but it was written by I think the guy's name starts with T something also. Tommy something. I've forgotten. You all can do your research. You can add up scripting here and a lot of things you can do from this place. All your projects can be set up from the Tommy. This is where the configurations happen. So you can do well to check in StarkNet Foundry book. Here you can check the project configuration and you will see what every single thing means for better understanding. So, but in the meantime, let's go back here and proceed. Yeah. So, and then the StarkNet Foundry.toml, which mostly is generated as a result of this Scarb.toml. And then it just helps you set your profile for deployment, etc. I haven't really fucked to this page, this. But the most important guy is your Scarb.toml, just know that. And then back here to your lib.cairo file, which is like the entry file to every StarkNet contract project. Oh, my screen stopped sharing.
But it's like his network has cut. Please, can anyone hear me? Let me know. I just want to know because this time where is silent.
You can continue.
Yeah, guys, can you see my screen again? So sorry for the break in. All right. So I've explained like all these different files you are going to come across when you spin up a project with StarkNet Foundry. So these are some of the commands you can run. Like take for example, if I want to compile the project, all I just have to do is say Scarb build. So with Scarb build is going to build everything, and if everything is correct, it's going to show finished. So it's here it's finished. And then when it finishes, it creates this target folder, which is where it generates our Sierra contract artifacts and other stuffs needed. So we can also choose to test. So with test, we use SNForge. I will just say SNForge test. And then first and foremost, it's going to build first, then it's going to try to run the test. So, you know, on default, we have already been given, what's it called? We have already been given a smart contract and a test inside. So that's what is running currently. So as you can see, the test went through correctly, and then we have 2 test pass, 0 failed, 0 skipped. And then we can try to check our test and see what we've written. We've written just 2 tests here, and we are good to go. So next, let's look at the anatomy of this smart contract that was generated for us. We'll look at what it looks like, then try to create our own smart contract, something very simple and minimal, just to introduce Cairo. All right, so this is a simple smart contract. In this case, we have, this is a trait. Now, trait is a concept we need to understand while learning from the Cairo book. But for those of you who have written Solidity, it's similar to your Solidity interface. So you know what interfaces are for, right? Can someone just remind me? Well, if you can't, I can. So interfaces are used for like 2 primary reasons. First, for either implementation or interaction. That is, you can use the interface of a contract plugged with its contract address to interact with it. And also, you can use the interface of the contract to have access to its implementation. So that's what this trait is used for. So this trait defines the contract, the functions being contained in our smart contract. Yeah. So there are a lot of things you need to know about this guy, but just for now, just look at them as interfaces, as traits. So next, we have the whole smart contract in here, which is denoted by the smart contract, StarkNet contract attributes. So this is another thing I need you to know. In Cairo or Rust, you are going to be noticing these things, mostly in everything you are writing. They are called attributes. They determine the behavior of whatsoever stuff we are working with. Like, for example, with this contract, with these attributes, the compiler is going to know that, hey, the next thing I'm reading here is StarkNet contract. And also with these attributes, the compiler is going to know that, hey, this guy is an interface, stuff like that. We also have another attribute here, which is for the storage. Manda, do you have a question?
So this guy is where to this man did not even know that the time.
Can someone mute Emmanuel? All right. So the next thing we have here is, this is the interface, like I said. Then this is the contract. Now within the contract, we have like 2 things. There are 2 things we contain in a contract. In every contract, from Ethereum or the rest, you know, a contract contains 2 things: state variables and then the logic or the functions to manipulate those state variables. The other things are spices. What are those spices? They can contain events which can be emitted after inside the functions, and then a bunch of other stuffs. But the main things being contained in a smart contract are the storage or the state variables, and then the function implementation. So in Cairo, you are going to experience a new way of writing your state variables. So So you know in Solidity before, after you initialize your contract, you can just declare your state variables at the top. But in Cairo, you have to declare your state variables inside of this struct called storage. So it's inside here that all state variables exist. Like take for example, we have this state variable called balance. We can also choose to add other state variables here, like take for example, owner. And then we call owner contract address. So let me try to import it. Yeah, so there you go. Here is inside of this storage struct is where you are going to add all your variables, all your state variables that you are going to be mutating. So from your Solidity, just know that here, you won't just declare them anywhere like this. Like try to declare a state variable here. No, it won't work. For it to truly work and for the smart contract to know, for Cairo contract to know, it has to be inside of this storage struct. Yeah, so enough of the storage. So the next thing we have here is the implementation. So in Cairo, every trait must have an implementation. So in this case, we define a trait which is called I hello StarkNet. It can be anything, but we mostly use the I to start it to signify that it is an interface. And if you remember in Solidity, we are also doing the same thing. How about now? Perfect. So here now we have this implementation. So this implementation is the implementation of this I hello traits. And then if we write this implementation here, we can be able to implement or write the implementation of all the functions that have been defined inside of this trait. Inside of this contract, mind you, we can have multiple traits, we can have multiple implementations. If they all get deployed, we are going to have access to all these traits and all these implementations in Cairo. So this is just the simple basics of all you need to know about Cairo. So next now I'm going to clear this. Then we are going to try to write a very simple Cairo contract. That is the basics. So the idea says we should work with the basics. So let me clear this guy. And then the first most important thing I like to do is to create a new file. So in this file, I'm going to call it counter.cairo. So this is the file where I'm going to be writing the contract, the counter contract that just increments and decrements. That's just the two things we are going to be writing today. All right. So now, first and foremost, what we are going to do is we are going to start with the interface. So let's define the traits of the smart contract. What are the functions that we need within this contract? So the logic is going to be very, very strange to a lot of you, but I urge you guys to start with the stacking challenge. And I trust me, within your first 2 trials, you will understand everything I did inside of this class. I counter. The next thing we are going to impute here is called a generic. So a generic in this space stands for like a placeholder or an argument. So in this case, we are going to be making changes to the contract state. So the trait we are implementing now, the trait we are defining now, does not have the contract. Oh shit. Yeah, I'm back. So this is defining the traits, and then you have to like insert the attributes, right? Which is StarkNet interface to signify that this is a StarkNet interface. Then we are going to define all the next we are going to define so the first function. To write a function in Cairo, you start with fn, and then this is what it looks like. I can just write the function increments. So the first thing you need to do, if it is a state changing function, in Cairo, the first value is always like the state you are going to be mutating, which in this case is the state of the contract. So in this case, we are going to reference it as self. And then self, then the type is C contract state, right? So it is a state changing function. In Cairo, to signify that it's a state changing function, you have to reference the state. So what we are doing now is that we're making reference to the state and then we are changing it. So like we're referencing this particular storage location and then we change it, which is the state of the contract. So the next is if there's any argument within the contract, maybe there's a particular amount we want to be incremented. So we want the amount to be dynamic. So we can just add that here. And then the amount in this case is U256. So this function doesn't return anything. And then we are going to just terminate this guy. So we have our first function. So the next function is to decrement, which auto-comment has already done this for us. Then the last function is going to get the, let's call it get value, just how it is suggested for us. But this time around, get value is not it's a read function. So increment and decrement are write function. That's why first and foremost we are referencing the states using ref self. But if it is a read function, we are not going to be referencing. All we are going to be doing is we are going to be taking the snapshot of the state. So to take a snapshot, we are going to be using the at word. Then lastly, what we have here is the return keyword. So you remember in Solidity, if you want it to return, we are going to say, after writing the function, we are going to say returns, right? Then specify the type that it returns. But in Cairo, all you just have to do is use this arrow and then specify the specific type that is going to get returned. So these are the three functions that are going to be implemented in our smart contract. Currently, they are being defined in the interface. So next, what we have is the StarkNet contract. So let me call this mod and then define the contract. So the contract name is counter. And then this is where I'm going to be writing all my implementation. So for the compiler to know that this is a StarkNet contract and implement all the traits that a contract should have, I'm going to add the attributes, which is as suggested, StarkNet contract. All right. So for me to be sure that this thing, everything is working, all I'm going to do now is import this to the lib every Cairo project. So for me to have access to this, I'm just going to say public and make this public mode, and then I will import counter. And then with this, I'm going to have access. So can you see the compiler is already reading this? And if there's any error, I can be able to see. So let me hover this and what's it saying? Contract must define a storage struct. So by default in Cairo, if every contract must define a storage, even though the storage is going to be empty, just know that you must define that storage struct. So let's do that, and then you see the error is gone. So this is a struct. I'm going to say struct and then call it storage. This is the name you must use by default, and then add this attribute to it so that I know that it is our state. It is our state. So I'm going to write storage. So that is going to treat this struct as a storage. So as you can see, even though it's empty, the error, it is gone completely, and it is being known that this is in storage. So let's add our first state variable inside of it. So it has already suggested it. Our first state variable is value. So this is the value we are going to be mutating, changing, and then sorry. All right. So we have done the most important thing. First, we define a trait, and then we define our contract, which is where the whole contract logic is going to exist. We define our storage, where the state variables that we are going to be mutating are saved. So the next step is to begin the implementation of the traits that we wrote. So let's write the implementation. So we're going to say, to write an implementation, you start with the impl keyword, and then you write the name of the implementation of what now? I counter. So I counter is going to be what we are working with. So I counter is the trait we are implementing. Then the last thing now, remember I told you we are going to be mutating the states. But then what we have here is the generic, which is like the placeholder for this real state of the contract. So here, instead of putting the generic, we are going to pass in the real state. So the state is known as contract state. And then with this, we can go further to write our implementation. So it's going to be showing us an error here. And then if you check the error, the error says trait not found. So why is trait not found? Trait not found is because we are trying to use I counter here, but we didn't import it into this particular scope. So there are also scope in Cairo. So this interface, for this to exist, we have to bring it into this contract scope. So to do that, we use the use keyword, and then we also use super. So super regards to everything that is outside of this contract. So everything outside of here can be accessed through super. And then as you can see, I counter is already there for us. And then we terminate this and it is successfully imported. So the error has left I counter and the error is back to the implementation. So what does the error say? It says not all trait items are implemented. So why do we have this error? Because we have written 3 different functions within this trait, and then we are saying that this is the implementation of this trait, but then all the functions are not being implemented. That's why we're getting an error. So we'll keep getting this error until we implement every single function. So let's do that. So the first function we are going to be implementing is the increment function. So let's call it function increment. Now this function is a state changing function, and then remember we have to reference the state. And then instead of putting T contract state, we pass in contract state, and then pass in the amount, which in this case is U256. And then we go further to write in the implementation. So to write in the implementation, first we need to get the previous state. So to read the state variables in Cairo is very easy. So let's read it. So first and foremost, let's define a new variable, which is the current value. And then it's equals to, so self in this case is the state of the contract. So to read it, we'll just say self dot. So self in this case is the same thing as like this storage. So if we type self, we can have access to everything here. So we can just say self dot value dot read. So we are going to read the value now. And then with this, we have successfully read the value. Then to increment, we are going to add whatsoever current value we have with the new amount we are having. Write it back to storage. So what we are doing here is that we are reading from storage. The next thing we are going to be doing is writing to storage, which is the 2 most basic things to do as a smart contract developer, right? So next, we are going to say self dot value dot write, and then we pass in current value plus amount. So this is going to take the current value, which is the last value, what we read from storage that is saved here, plus the new amount we are passing to the function, and then it's going to give us, it's going to increment it for us. So next, let's try to implement the function to decrement. And then in this function too, we are going to reference self, checking the contract state, passing the amount, and then do vice versa. Now, vice versa is we are trying to decrement the previous value. So we are reading what is the last value being passed in here. So lastly is going to be the function to get value. And then what this function does is easy. This function just tries to read the value from storage. So you just do self.value.read. And then remember, this is not a state changing function. This is a read function. That is why it must have this at contract state instead of using the ref. So what this does is taking a snapshot of the state. But what this does is that it's referencing the state to be able to change the values. So with this, we have written a very, very simple smart contract with Cairo. Now, there are a lot of things to be learned. I just gave you guys a high level overview, but because we are not we don't have time to introduce the basics of this language. What we are just doing, we are doing with from the curriculum. So I'm going to give you guys time now to ask questions, simply because you're like I always say, feel free to go to the docs, start learning about this, and then come to my DM and I'll be available to answer. But the first two go-to looking app, confusions, and then we can proceed from there. So questions now. No guys, so we don't have questions.
It's our first time, so I think the class is a bit confusing for now. But we'll have to go and rewatch the video again. Then go after it, like everything. You know, come back.
Yeah, not just rewatching the video, you have to go back like to the hello world, the official get started, and get started with the syntax directly. But you guys know this bootcamp is for you guys to be smart contract devs. So that's why we're only showing you. And to be like a pro in this, you have to start from like the ultimate beginning. All right, guys. So in the absence of any other, to avoid the bunch of confusion, so you guys should. Yeah, guys.